number patterns, knowledge and routine test. Now this, I'm going to work through 3 basic tests, 50 marks each, with the number patterns where the first one, this one is just knowledge and routine procedures. So we're just going to test, do you know your stuff? And then if you don't know your stuff, if you still struggle with this one, I suggest go back to the What You Must Know video and go watch that again until you're comfortable with everything you must know. And then the second test is complex procedures, and then the third test is a final exam type test, which looks a lot like what you can expect in your matric final exam. So for this first test, the first question for 5 marks is proof, which I'm not going to do now because I did this question in the previous video with the proof of the formulae for this chapter. So it says prove that the sum of n of an arithmetic series is given by the formula Sn is equal to n over 2, 2a plus n minus 1d, where a is the first term of the sequence and d is the common difference. Okay, so this first one for 5 marks, you must prove this formula, which is a proof that I have done in the video on proofs. The second question says, state whether the sequence root 3, root 12, root 27, okay, state whether this sequence is an arithmetic or a geometric sequence, giving the common ratio or the common difference. Okay, so I must first state if it's geometric or arithmetic, and then if it's arithmetic, I will state the common difference, and if it's geometric, I will state the common ratio. Now it's a bit difficult to see if root 12 minus root 3 and root 27 minus root 12 is going to give me something significant, and even if I divide them also. I'm just going to simplify this a little bit first. Root 3, there's not really much I can do about it. Root 12, I can write as a product of prime factors. 12 divided by 2 is 6, divided by 2 is 3, divided by 3 is 1. So 12 is 2 squared times 3. And if I take the root of this, because I want the root of 2 squared is 2, and the root of 3 I can just write like that. And then 27 I know is 3 cubed, but I can just write that like this also if I really need to. And this I'm also going to write, instead of 3 cubed, I'm going to write it like this, 3 squared times 3, because I know I want to take the root, and the root of 3 squared is 3, and then that other 3 just stays under the root. Okay, so now I can easily see I just actually add a root 3 every time. Root 3 plus root 3 plus root 3 plus root 3. So this is what's happening here. But I can just, for the sake of it, go and write down d is term 2 minus term 1, which is 2 root 3 minus root 3, and that gives me root 3. Or d is also term 3 minus term 2, and I already have d, so why would I work it out twice? This just makes me 3 root 3 minus 2 root 3 is root 3. Double checking myself just makes me a better mathematician. So I double check myself. That's why I worked it out twice here. Great, so I can now say that this is an arithmetic sequence. They asked me, always when I've worked out a lot of things, just go back and make sure you've answered now the question. The question says, State whether the sequence is arithmetic or geometric. It's arithmetic, giving the common ratio or common difference. The common difference is root 3. Okay, question 2.2 says, use a formula to find the sum of the first 10 terms, leaving your answer in simplified surd form. Now, simplified surd form, it's a root form. Surd is also another word for root. It's spelled like this, which is also a root, just another word. So the fact that they say leave it in simplified surd form just actually tells me I'm going to have to work by hand and not by calculator. So the sum of the first 10 terms, I'm going to use the formula. They say use a formula to find the sum of the first 10 terms. The sum of an arithmetic sequence is n over 2. It's this formula there. Plus n minus 1d, like that. And then I'm just going to substitute for 10 terms. So n is 10. My first value is root 3. And n is 10 again. And my difference that I've worked out is also root 3. Okay, so now I can just simplify a little bit. 10 over 2 is 5. Just going to leave this 2 root 3 for the moment. This is 9 root 3, can you see? Because 10 minus 1 is 9. And then 2 root 3 plus 9 root 3 is 11 root 3. You can treat this the same as 2x plus 9x. And that gives me 11x, where my x is just root 3. And then 5 times 11, I can multiply 55. The root 3 I can just leave like that. Okay. Question 3 says, let's make some space here again. Question 3 says, find the first 3 terms for the sequence described by, and they give me a formula. The formula that they give me is this. Okay. Find the first 3 terms. Now I can immediately see, because I know my work very well, that this is AR to the power of n minus 1, which is the general form of a geometric pattern where my A value is 2 and my R value is minus 2. So logically I can go and write down the first. This means my first term, A is the first term and R is the common ratio. So my first term is 2 and I multiply by minus 2 the whole time. So 2 times minus 2 is minus 4 times minus 2 is 8. So you can really just go and do that. But if you didn't see that, you can also just go and work out term 1, term 2, and term 3 by making the n 1. So this is to the power of 0, which is 1 then. 2 times 1, or you can use your calculator. This gives you 2. And 2 to the power of minus 2 times 2 minus 1. I just make the n value 2 now. This is minus 4. You can use your calculator or your head, depending on which one you trust more. And 2 times minus 2 to the power of 3 minus 1 is 8. This is 8. Minus 2 squared, which is 4 times 2 is 8. Alright, so you can work out the 3 terms like that, or you can just logical reasoning it like that. And then question 3.2 says, show that this sequence is geometric. Now, to show that something is arithmetic or geometric, what do? For arithmetic, I use term 2 minus term 1 is the same as term 3 minus term 2. For geometric, I use that term 2 over term 1 for geometric should be the same as term 3 over term 2. Then it's a geometric pattern. So I'm going to just work out the left-hand side. Term 2 is minus 4 over term 1 is 2, which gives me minus 2, but I already know anyways my r is minus 2. And for the right hand side, term 3 is 8 over term 2 is minus 4. 8 over minus 4 is also minus 2. So that tells me that it's a geometric pattern or a sequence. Okay, for question 4, I'm just going to continue working here. For question 4, they give me this plus 2 plus 5 plus 20. Okay, and they say express this in sigma notation. They give me this, express minus 4 minus 1 plus 2 plus 5 what plus 20 in sigma notation. Now for sigma notation, if you know exactly how sigma notation works, it's not a big problem to see immediately what you must do. In sigma notation, I will have the sum of, I have a formula here, so I need the formula of this. Okay, and then they say where usually for number patterns my formula is in terms of n. So from where n is 1 until n is the last one there. Now I can see my n1, n2, n3, n4 here, but I don't know which term is that, so I must just maybe once I have the formula get that. Before I start finding a formula, I must just first always decide, am I working with arithmetic or geometric here? Okay, I need the formula and I need to know what term is this before I can go write in sigma notation. So I'm going to go work that out. Minus 1 minus minus 4 is 3. 2 minus minus 1 is 3. 5 minus 2 is 3. So can you see that term 2 minus term 1, term 3 minus term 2, and term 4 minus term 3 also all give me 3. So this is an arithmetic series with A, my first value, minus 4. D, my common difference, 3, and then it's not really difficult using this formula. Then I know I'm going to use the arithmetic formula, and the arithmetic formula, I just substitute that, minus 4 plus n minus 1, 3, and I always put my d in brackets there. So this is minus 4 plus 3n minus 3. I just multiply the 3 into the brackets, and this gives me 3n minus 7. So my general term in sigma notation is going to be 3n minus 7. Okay, and then I must just calculate my n will go from 1. If I substitute 1 in there, you can quickly test, you're supposed to get minus 4. And if you substitute 2 in there, you should get minus 1. I just actually want to know what term is that. So 3n minus 7, whatever I substitute n for, should give me 20 for that last term. So 3n is 27, that means n is 9. Okay, great. So I've got my last term is the 9th term. From my first term to my 9th term, this formula, I just add all of this up, and this is this sigma notation of this pattern. Okay, question 5 says the first term of a geometric series is 2. I'm working with a geometric series. Now this is the formula for a geometric series. The first term of a geometric series is 2, and the common ratio is 1.5, which I'm just going to write as 3/2 because that's one term, and this is sort of a lot of numbers. This is just one expression, and it just makes it easier. Okay, so then they say determine the value of the fifth term for 5.1. Now I already have this formula. Can you see if I have the A and the R value? My general formula will be 2 times 3/2 to the power of n minus 1. So this is my general formula. Now you can really just go and do that, use that. Term 5 should be 2 times 3/2 to the power of 5 minus 1. Calculator that. It might in this case seem easier to just go and this gives me 81/8, or if I write it as a decimal, 10.125. 10.125. (81/8), right. This is using the formula. You might be tempted, if you know the first term is 2 and the common ratio is 3/2, to take 2, multiply with 3/2, it gives me 3. Multiplied by 3/2, it gives me 9/4. Multiplied by 3/2, and with this method, just go and work out the first, second, third, fourth. You work out the fifth term, and then you have it, which is perfectly fine if they ask the fifth term, but if they ask the 500th term, that could be a bit of a problem to do it this way. So it's better to just use the formula. Alright, so that is the fifth term, and for 5.2 they say find the sum of the first 10 terms correct to 2 decimal places. Now the 2 decimal places already gives me a hint. I'm going to just put that in my calculator. So the sum of the first 10 terms, this is a geometric pattern. Then I work with the formula r to the power of n minus 1 over r minus 1, and I just substitute in there for 10 terms. So my a value is 2, my r value is 3/2, and I'm just going to put some brackets over there also. I know it seems like double brackets there now, but my r value to the power of n is 10 minus 1 over r is 3/2 minus 1, and you can just put all of this in your calculator. If you have your calculator close by, work this out on your own and see if you get the same answer as me, because a lot of the times just pressing one wrong button gets you the wrong answer, and practicing working things out on your calculator while you have someone next to you giving you the right answer so that you can check your answers with is a good idea. Okay, and this gives me 226,660, so to 2 decimals I can round it off as 666. Alright, So that is the sum of the first 10 terms to 2 decimals. Another thing that's also a very good idea, while I'm just discussing good idea using your calculator with me, another thing that's also a good idea is whenever I work out problems in any of these videos really, just take down the question that I'm working out and then pause the video. So for instance, if I now say they give me the sequence 4x32, and then for 6.1 they say find the value of x if the sequence is arithmetic, and for 6.2 they say find the value of x if the sequence is geometric. So for this one I want to find the value of x if the sequence is arithmetic, and for 6.2 the same thing, find the value of x if the sequence is geometric. So it might be a good idea to write down the question, pause the video, try it on your own, and then play and compare. Because we only really realize what do we struggle with and where we are stuck and what we don't know once we start doing it on our own. We can easily follow somebody else and see, oh yes, that looks easy. But the moment you start doing it yourself, you get stuck. So start doing it yourself and see where you get stuck. Then you can play the video and just get help on the bits where you got stuck. Okay, so for this there's two things you can do for the arithmetic. There's a formula in the What You Must Know video that I did where you can just use this term 2. If I don't have that, will be those two added divided by 2, which I'm just going to do. So that's 4 plus 32 over 2. This is 36 over 2, which is 18. Okay, but if you didn't know this formula, or if you forgot about this formula, something else you can do. If this is an arithmetic pattern, the constant difference will be the same. So 32 minus x will be the same as x minus 4. Because it's an arithmetic pattern, and then you can just go and work out x by solving this equation and you should get 18. Alright, so term 2 is actually x. Okay, and for the geometric one, there's also a formula that the second term, let me just write term 2 there in the formula and then replace, yes. There's also a formula that term 2 is plus or minus term 1 times term 3. So there's a formula, but yet again, if you forgot about this formula, you don't know it, or you're not comfortable using it, you can also go and say that there's a constant ratio if it's geometric. So 32 over x should be the same as x over 4, like that, and go and solve x from there. If you still don't know what to do with this, cross multiplication, x times x is x squared, and 32 times 4 is 128, I think. Yep, 128, and then you can work from there. So if I've got this, I can just say plus or minus a root 4 times 32, which is root 128, and I can just substitute that in my calculator. That's 8 root 2. So plus or minus 8 root 2, this is the value of x. Okay, and whenever you they don't say, no, this question don't say leave insert form, so I'm not going to, whenever it doesn't say leave insert form, don't leave it insert form. So I'm actually just going to make this a decimal rather by pressing this SD button there. 11.313, so I can round off to 11.31. And at most of these questions, they will actually say this is a geometric pattern or a geometric sequence with x bigger than 0 or with x smaller than 0. If they state x must be bigger than 0, then your answer will be plus. If they state with x smaller than 0, then your answer will be x is minus 11.34. But in this case, they really just stated find the value of x if the sequence is geometric. So then the value of x can both be positive and negative 11.31. So I'm just going to leave it like that. Right, question 7. I'm just trying to decide if I should start from the top again. I'm scared there's not enough space once I've started with the question. I don't want to do half a question and then rub it out and do the other half there. So it says show that the infinite series like this is convergent. Show that it's convergent, and then also show that this series will never exceed 6. It will never be bigger than 6, so it will be smaller than 6. Right, so what I want to do first is show that it's convergent. Now I know for convergent series I can use this formula, a over 1 minus r, but I must first just show that this is convergent. Now this bit there is the key. This means if r lies between minus 1 and 1, then the series is convergent. If it doesn't, if it lies bigger than 1 or smaller than minus 1, then the series is divergent. Meaning if my common ratio is a fraction. So what I want to do to show that this is convergent is I'm going to work out r first. You see how the knowledge applies here. I know this, and therefore I know what to do. For convergent series, r will be between minus 1 and 1. So I'm going to work out r. Convergent series and divergent series is always geometric. So I'm going to say term 2 over term 1, and this is minus 3 over 8. And just to make 100% sure, I'm also going to distrustingly take term 3 divided by term 2. You can calculate that or use the fact that divided by minus 3 over 1 is the same as multiplied by minus 1 over 3, and then that gives me negative 3 over 8 also. Okay. So yes, definitely my r value is negative 3 over 8, and that lies between, it's a fraction between 0 and minus 1 actually, because it's negative. But that means that r lies between minus 1 and 1. So perfect. So that means that this series this series is convergent because the r is there. Okay, and then I must show that this will never exceed 6. So I'm just going to work out the sum to infinity. My a value is, the first term is 8 over 1 minus r. My r value I worked out is minus 3 over 8. And note how I've got two minuses there, the one from the formula and the other one from the r value. Two negative values will become positive. So this is then 8 over 1 plus 3 over 8. You're more than welcome to substitute minus 3 over 8 into your calculator also. and that gives me 64 over 11, but that doesn't tell me much. I'm just going to make it a decimal, and then it gives me 5.818181, which is 5.8181, 5.81. It's not reciprocal. What is that word? But repeated. I know the word very well, but it just escaped my mind at the moment. Recurring. 5.81 recurring. Okay, so, and then this is definitely smaller. 5.818181 is definitely smaller than 6. So I've showed that the sum to infinity is smaller than 6. Okay, so question 8, they say, given that tk is 5k minus 3, now don't get freaked out. They've just taken the usual tn is 5n minus 3 and just replace the n with a k to just make it look a bit different. You're going to do exactly the same. This is an arithmetic. Can you see? It's a linear equation. That's arithmetic series sequences. Given that this, show that this sequence is arithmetic. So first, given this, show that this series is arithmetic. So what I want to do is, I want to just get the first 3 terms, because for arithmetic, what I do is I take term 2 minus term 1 and term 3 minus term 2. But I don't have them, so I'm just going to work them out. So term 1, I'm going to work with a little table quickly. K is my term number for term 1, 2, and 3. Then the term is tk. So if I substitute 1 in there, 5 times 1 minus 3 gives me 2. 5 times 2 minus 3 is 10 minus 3 is 7. And 5 times 3 is 15 minus 3 is 12. Okay, so I can quickly generate a little table, and then I can just show that term 3 minus term 2 is 12 minus 7, which is 5, and term 2 minus term 1 is 7 minus 2, which is also 5. So I've got a constant difference 5, and that means that it's arithmetic. Okay, for 8.2, for 8.2 it says, I think I'm just going to make some space and start at the beginning again. There's only 10 questions in this test, so we're almost there. Stick with me for another few minutes. They say determine the value of n if the sum of k from 1 to n of 5k minus 3 is equal to 2, 2, 3, 5. Okay, so how many terms have I added if this sum is 2, 2, 3, 5? Now I know this sum with the formula from 1 to n is just another way of writing the same thing, or there's a formula for this. This is arithmetic, so I use the arithmetic formula. This is the formula to also work out that sum. So I've got the sum is 2, 2, 3, 5. 2, 2, 3, 5. I don't have the n, I want to work out that. But I know my first term is 2. I just work it out in the table. And I know my constant difference is 5. Okay, so now I've just got an equation that I must simplify a bit. Going to multiply both sides with 2 to get rid of this. So 2235 times 2 is 470 is n. Okay, this is one term because there's brackets, so this whole thing is one term. If I multiply this whole term with 2, I can just get rid of that 2. So nothing's here going to be multiplied with 2. I multiplied outside with 2. Okay, 2 times 2 is 4, and 5 times n is 5n, and 5 times minus 1 is minus 5. So this is 5n minus 1. 5n minus 1. Like that. And then I'm left with, I'm just going to multiply in this n, 5n squared minus n. And I'm going to bring this over also. Minus 44070 is equal to 0. So this is a quadratic equation. I think the fastest way to find n will just be to use the quadratic formula. Minus b plus or minus root of b squared minus 4ac over 2a. To find the value of n, you're going to have two values here actually. Where a is 5, b is minus 1, and c is minus 4470. Okay, so I'm just going to put that in my calculator quickly. Minus 1. I'm just going to put plus first. B is minus 1 squared. Minus 4a is 5. C is that. Over 2 times a. A is 5. 2 times a is 10. Okay, so that gives me 30. So n is either 30 or if I change that plus to a minus over there, n is I just want to make sure it doesn't make sense that the one is a complete nice number and the other one is a fraction. But yes, there's nothing problem there. It's minus 149 over 5 or minus 29,8. Minus 29,8. Right. Now, since n is the number of terms, and if you think about it, this question said determine the value of n. So how many terms will I add together to make this get 2235? I'm not going to have minus 29,8 terms. First of all, I'm not going to have a decimal amount of terms, and it's not going to be a negative amount of terms. So this is out. So then I can say 30 terms will give me 2235 when added, or the sum of 30 terms, or n will be 30 or something like that. But just make a conclusion that this is not a valid answer, this is your answer. Okay, right, so that's question 8. Question 9 and 10 quickly. Question 9 says determine the value of n if 4 plus 2 plus 1 plus to n terms gives me 7 and 31 over 32. 31 over 32. Okay. So 4 plus 2 plus 1 plus what plus what plus what plus what gives me 7 and 31 over 2. Now can you see this is divided by 2 divided by 2? Hopefully. or I can say 2 over 4 is a half, 1 over 2 is a half. So I've got a the most important thing that you must not make a mistake is don't work with arithmetic when it's geometric and vice versa. So this is clearly a geometric pattern. And in this geometric pattern, I've got my first value is 4 and my R is 2 over 4, which is a half, or 1 over 2, which is a half. So my R is a half. Okay. So the sum of a geometric pattern looks like this: a times r to the power of n minus 1 over r minus 1. And they tell me that the sum of this pattern is 7 and 31 over 32, not 2, 32. My first value is 4. My r value is a half to the power of n minus 1 is my r value is a half minus 1. Okay, so I'm going to try and solve this. I'm just going to simplify this a little bit first. A half minus 1 is minus a half. So I've got 7 and 31 over 32 is equal to 4. A half to the power of n minus 1 over minus a half. And then I want to get rid of this. You can actually write this as a, let's write this as a as improper fraction. 7 times 32 plus 31 is 255. So I've got 255 over 32. And then I can actually just cross multiply. I think I'm making it more difficult than it needs to be. 7 and 31 over 32. I'm going to take this in my calculator and multiply minus a half with it to get rid of this. So minus a half times 7 over 31 32 over 32 is equal to 4 a half to the power of n minus 1. And then if I divide by 4 both sides, this divided by 4 should be equal to half to the power of n minus 1. I'm just going to take that in my calculator. Minus, clear, minus a half times 7 mixed fraction, 7 and 31 over 32, like that, divided by 4 gives me minus 255 over 256. Minus 255 over 256. And then I just want to plus 1 to this to get that alone. So 1 minus 255 over 256 is equal to a half to the power of n, or I can write it as 2 to the power of minus n. And then this is then 1 minus 255 over 256. Can you see? Should just be 1 over 256. But you can really take this in your calculator and plus 1. It gives me 1 over 256 is 2 to the power of minus n. So I'm just going to take 256 shift fact. And that gives me 2 to the power of 8. So this is 1 over 2 to the power of 8, which is 2 to the power of negative 8, is 2 to the power of negative 1. And that means that n should be 8. Can you see the 2, the negative? So n is 8. So n is then 8. So if I add 8 terms like this, I should get that. Okay, last question. This is an interesting one. I hope you stuck around for this. I'm going to use trigonometry here. Right, so they say if cos x plus cos cubed x plus cos to the power of 5x, this is a convergent geometric series. Determine the sum to infinity for this series in its simplest form. Right, now can you see this is if it's a geometric series, it means my first value is cos x. Geometric series have a r value, should be cos cubed x over cos x, which is my second term over my first term, and cos cubed over cos is cos squared x. So that's my r value, and then the sum to infinity of this will be a over 1 minus r. So my a value is cos x over 1 minus cos squared x. Now I know 1 is sine squared plus cos squared. So sine squared plus cos squared minus cos squared, or you can just replace 1 with sine squared x plus cos squared x minus cos squared x, and this gives me cos x over sine squared x. Can you see that cancels out? In its simplest form, I guess you could say cos over sine is cot, because cot is the inverse, sine over cos is tan. So you can stop there, or you can go one step further, just saying that cos over, if I break these two signs, sine x times sine x, that this, can you see sine over cos is tan, so cos over sine would be cot. You can write this as cot x over sine x, and over sine x is also cosec. Cosec x, you can write this as cot x cosec x, but maybe that's taking it a bit far. I think if you leave it at cos x sine squared x, that's also fine. Alright, so cos x sine squared x, and that is question 10. I'm actually curious what the answer of this is, but I'm not sure the answer of this is in the book. Oh, it is. Let me quickly just find it. Yes, they leave it at cos x over sine squared x, so that's fine. Okay, alright, so that's perfectly fine, then leaving it there. Right, so that's the first test, knowledge and routine test. The second and third test will then get even more difficult, and then comparing test questions with this.